Okay. So in this lecture, we will discuss the next point, right, of unit number 3. So actually, we are going for the revision of that unit. Okay. So yesterday we have covered about the Verilog reserved keywords, right? Then Verilog arrays. Okay. So today that part we are going to cover. Verilog vectors we have covered. Okay. Okay. Now today we will discuss the Verilog arrays. Okay. Actually, the same part we have discussed in the VHDL also, right? VHDL in VHDL also, in that data types of VHDL we have used array, unconstrained type and constrained type. Okay. Now here the arrays are used with what we can say the same in the way that you are using in the C language. That means in case of this Verilog, whatever the array structure, array syntax, it is much similar to the C language structure, right? In C language also we are using the array. Yes or no? आपण वापरतो का नाही सी लँग्वेज मध्ये पण अरे. So in the similar context, the in Verilog also we are using the array, that as we are using in C language. Okay. Now the syntax, how you can declare the array in Verilog. So for that we have to study the syntax for the same. So what is the syntax for Verilog arrays? Data types, then array name, right? Then array indices. That means what we can say, it's range, or you can even mention the indices for that array. Okay. Now, for example, register B, right? So register is a data type. Okay. B is the variable. Sorry, B is the array name. So data type is register, array name is B, and array indices is 15 as to 0. That means 16 elements are present in that array. So this is the array indices. Now tell me one thing, when I will mention 15 as to 0, so which bit by default it will consider as a MSB? That means 0th bit or 15th bit? By default MSB will be 0th bit or 15th bit. We have studied this part in yesterday's lecture. MSB काय कन्सिडर करणार तो? 0th बिट कन्सिडर करणार का 15वा बिट कन्सिडर करणार? MSB. Can anyone? 15th bit. Very right. So always remember, first representation number is the MSB bit. Okay. And the second representation number is the LSB bit. Always remember. Now next, you can also what we can say, specify the array of vectors also. What is syntax to declare the array vectors? So again, data type, then vector indices. Okay, data type, then vector indices, then array name, then array indices. That means first register is a data type, then 15 as to 0, it's a vector indices. Now in this case it's a vector indices. Then you can give the array name, A, B, C, D, whatever that you want to mention. That is, C is the array name, and finally the array indices, that is 1020 1023 down as to 0. It's a array indices. So this is, in this way you can represent arrays of vectors, right? In this way you can represent the arrays of vectors. Similarly, in similar manner, you can mention the memory access part also. Okay. So in similar manner, you can mention the memory access part also. For example, variable name, then array indices, then vector indices, right? So in this way you can give the what we can say, the memory address actually, right? Memory address for that array, variable name, then array indices followed by vector indices. So in that way you can give the uh, or you can use the Verilog arrays for the memory address purpose, okay, from that array. Now this is the example of how to use this Verilog arrays. So we have a simple RAM model. So first part is a module, that means you can say it's a entity part, then register 7 down to 0, right? Then storage, it's the array name, and 15 down to 0 is the array indices. And what is 7 down to 0? It's a vector indices, and register is a data type. So register is a data type, 7 down to 0 is a vector indices, storage is the array name, and 15 down to 0, 15 as to 0 is a array indices, right? So in this way you can define the different arrays or vector arrays in Verilog. In case of counter also, you can use or you can define different array, okay? So this is again one example of use of Verilog arrays, okay? Now next part that we will discuss is structures and hierarchy of Verilog, okay? So structure and the hierarchy of Verilog. So how we are representing the structure and hierarchy of Verilog? So in hierarchical HDL structures that are achieved by the defining modules and instantiating modules. That means in case of HDL, first we have stop model, then we have internal model, or you can say the gate level model or component model, then you have different mux model. Now in this case, this top model means what? Your black box, that means your entity part, right? The top model is nothing but the entity part. Within that top model you can have different internal structural models, whatever the structures that you have used in that design. So within that top model you can have that internal internal structural models, okay? So this is a typical structure and hierarchy for this Verilog HDL, okay? Now how you can actually write this structure and hierarchy in Verilog? So first you have to write the module, that means whatever the module you are defining for, then module name, then parameter list, then port list, then declarations you can give, then instantiations you can give, data flow statements, behavioral blocks, task functions, and end modules, okay? So this is a typical flow, or you can say this is a typical syntax for the module declaration, okay? The same thing we have discussed in VHDL as a entity declaration, right? Within that entity declaration you can have the generic declaration, port declaration. That means that is the overall entity declaration, right? Same thing in case of Verilog, that entity part we part is similar to the module declaration part. म्हणजे VHDL मध्ये आपण त्याला काय म्हणणार? एंटिटी डिक्लेरेशन. Verilog मध्ये आपण त्याला काय म्हणतोय? मॉड्यूल डिक्लेरेशन, right? So that module declaration is much similar to the entity declaration. Here also we have to mention the module name. आपण तिकडे entity name द्यायचो का नाही? Module name, then parameter list, which parameters you are using. But the difference you can see here in case of VHDL, it's a typical structure for declaring the entity. That means you have to first define the entity, then you have to define its range or its bits range, then its type, okay? In Verilog also the format will become same, but the syntax will become different. But the syntax will, and the data types are also used in Verilog, it's much similar to the C language. बरोबर है? In case of Verilog, you cannot have that input standard dot vector. This kind of data type is not present in data type is not present in Verilog. It is only in VHDL. Here you have to use the Verilog data types. बरोबर आहे. VHDL मध्ये आपण इनपुट डॉट std डॉट स्टँडर्ड लॉजिक वेक्टर्स बरोबर आहे, हे सगळे डेटा टाइप्स वापरायचो. सो इन Verilog we have to use the Verilog data types, right, that we have discussed already. So this is a what we can say module declaration part. Then module header. So what do you mean by module header? So you have to start with the module keyword. Again I will repeat, module is also one of the reserved keyword. काल आपण बघितले का नाही, there are many reserved keywords that are present in Verilog that you should not use as a module name or anywhere in the your program. जे रिझर्व्ड कीवर्ड आहेत ते तुम्ही प्रोग्राम मध्ये कुठेही वापरायचे नाहीत, कारण ते रिझर्व्ड आहे. मग त्याचं मिनिंग काय राहिलं रिझर्व्ड कीवर्डचं, बरोबर आहे. सो यू हॅव टू स्टार्ट विथ द मॉड्यूल कीवर्ड. दिस इज ऑल्सो रिझर्व्ड that contains the input output ports. Then you have to give the name to your module, that means module name. Here in this case we have given the ALU as a module name. Then you have to start port declaration with the input outputs and inouts, right, followed by the what we can say the data type declaration. बरोबर आहे. म्हणजे आपण जे त्याच्यात इनपुट कुठले वापरणार आहोत, इनपुट कुठले आहेत, आउटपुट कुठले आहेत, किंवा बाय डिरेक्शनल म्हणजे इन आउट कुठले आहेत. सो दॅट यू हॅव टू मेन्शन इन दॅट मॉड्यूल हेडर. अगेन each direction are followed by one or more input output names. Okay, so with the same output or input you can declare the many names, or you can declare the many input output variable, but that must be a input type only or output type only, whatever, right. And here each input what we can say the input names should be separated by the comma. That means, for example, input 15 down to 0, that means it's a 15 down to 0 register A B, that means these two registers that of 16 bit, and this is the input, it is of 16 bit, and A and B is the input. So you have to separate this A and B with the comma. You have to separate this A and B with the comma. So likewise you can declare the module header part also. Again, the port declaration part, in case of in VHDL also there is a port declaration part. So input, in out are declared as wires, output ports can be declared as a registers. Okay, so you have this module S1. So first you have declared the S1 is the module name. Then A, B, C, D, E, these are the variables that you have declared. Now this is the header. This is the module header. Now we have to specify within that A, B, C, D, E, which are the inputs and which are the outputs, right? Which are the inputs and which are the output parts. So in that case, you have to start with the input, then 1 as to 0, that means it's a 2-bit input, A comma B, right? Input C, that means we haven't mentioned the bus here or bus indices. That means what? It's a single bit input. बरोबर आहे. जेव्हा हे 1 as to 0 हे काय दाखवतं? It's a 2-bit input. आणि जेव्हा तुम्ही नुसतं C लेता, by default it will assume it's a single bit input. There you need not to write the bus indices. बरोबर आहे. Then output, obviously output register 1 as to 0 and D, that means this D is the output register and which is of 2-bit. Here output E, that means this E is also output, but this is not a register and that is a single bit. बरोबर आहे. म्हणजे जिथं तुम्हाला मोर दॅन 1 बिट द्यायचं असतं तेव्हा तुम्ही असा 1 as to 0, 15 as to 0, 5 as to 0, व्हॉट एव्हर असा बस इंडायसेस मेन्शन करायचा. आणि जिथे तुम्हाला सिंगल बिट वापरायचं आहे तिकडे फक्त तुम्ही ते व्हेरिएबलचं नेम द्यायचं. ओके, सो इन धिस वे you can declare the modules, right? And again I will repeat, this module is much similar to the entity part in the VHDL. VHDL मध्ये पण आपण असंच करायचो का नाही? एंटिटी, पहिले इनपुट आउटपुट कुठले आहेत, मग ते किती बिटचे आहेत, बरोबर आहे, हेच सगळं करायचो आपण. सिमिलरली इन Verilog also we have to declare this module part, but with some different syntax. That's the only difference, right? So this is Verilog style, and this is the ANSI C style. So this is also one of the HDL language that is used for the digital design purpose. Okay, so in this way you can what we can say discuss, or you can declare the port declaration and module declaration. Okay, then next part, parameters. Okay, next part is parameters. Now parameters, actually what do you mean by these parameters? So for to declare the parameters, it's what we can say you have to names to some constant values. So I will say in case of Verilog, these parameters are nothing but the constants, in very much similar to the VHDL. Okay, this parameter is much similar to the constants. VHDL मध्ये आपण कॉन्स्टंट्स वापरायचो का नाही, आपण तिथे डायरेक्ट डिक्लेअर करायचो. फॉर एक्झाम्पल x इज इक्वल टू 5, दॅट मीन्स इट्स अ कॉन्स्टंट. ओके, सो इन Verilog इफ यू वॉन्ट टू डिक्लेअर सम कॉन्स्टंट, राईट, तिथे आपण VHDL मध्ये कॉन्स्टंट डिक्लेरेशनला काय वापरायचो, आपण जेनेरिक डिक्लेरेशन वापरायचो, राईट. सो हिअर these parameters are much similar to the constant declaration part. By using this parameter, you can what we can say declare some constant expressions. Okay, for example, so this is the parameter declaration part. So in this default value need to be set at declaration time, then 32-bit wide by default, but may be declared of any width. So if you haven't mentioned any range, it will considered as a 32-bit. But if you mention that bus indices, that means range, it will consider that much bit only. The example is here, parameter. This is the parameter. Then its bus indices is 2 down to 0. That means it's a 3-bit parameter. Parameter name is ideal, and it's a obviously 3-bit decimal 0. That means it's a 0 0 0. It's a value, right? It's a constant expression. बरोबर आहे. आपण हे कसं डिक्लेअर करायचं ते कार्ड शिकलो, डेटा डिक्लेरेशन टाइप. ओके, द what we can say the number of bits, then semicolon, then the what we can say the type, that means whether it is a binary, decimal, hexadecimal, octal. If it's a hexadecimal, then you have to write the H. If it's a octal, then you have to write the O. It's a binary, you have to write the B. That means if suppose this is a 3-bit binary number, then how you can declare 3-B0. That means it's a 3-bit binary number and which value is 0 0 0. Or you can write 3-bit 0 0 0, no problem. This is also valid. Similarly here 3-D0, that means it's a 3-bit decimal number which value is 0 0 0, right? So in this way you can use this parameter declaration part. Okay, so this is the inside module. That means if you want to declare parameter, this inside module, and this is in module header. Okay, so in case of module header also you can declare this parameter part also. So for to declare inside module, this is the example. So parameter, it's a parameter name is a size, right, and its expression is 32. Okay, now tell me, if you directly write this 32, what it means by default, what it will consider? It's a integer value, right? 32 it will consider as a integer value. Okay, and I haven't mentioned here range. इथं मी रेंज मेन्शन केलेली नाहीये, त्यामुळे त्याची बाय डिफॉल्ट रेंज तो किती घेणार आहे, त्याची बस इंडायसेस किंवा ज्याला आपण रेंज म्हणतो ते मेन्शन केलंय का, इथं नाही केलेलं. मग बाय डिफॉल्ट त्याची व्हॅल्यू किती घेणार आहे, 32-bit. दिसतंय का नाही वर तुम्हाला इथं 32-bit वाईड बाय डिफॉल्ट. म्हणजे जर का तुम्ही ते 2 डाऊन टू 0 2 किंवा 2 एस टू 0 असं डिक्लेअर केलं नाही ते आयडियल, तर तो बाय डिफॉल्ट ते आयडियल हा जो पॅरामीटर आहे तो किती बिटचा धरणार आहे, तो 32 बिटचा. पण इथे मी ते मेन्शन केलंय, सो इट विल कन्सिडर इट ॲज ओनली 3 बिट, right? So in this way you can declare this parameter, right, inside the module as well as in the module header, in the module header. Clear with this? Okay, so this is the again example. Okay, so this is module header, right? Module adder, adder is the module name. A, B, C in, S, C out, and clock, these are the variables. Then I have declared this parameter, parameter n is equal to 8. So this is a constant, right? N is the parameter name, its value is integer 8. Okay, and again this input, right, n minus 1 as to 0, a comma b. So its n value is 8, that means 8 minus 1, that means 7 as to 0, that means a and b are the inputs of 8 bit. म्हणजे ए आणि बी हे दोन 8 बिट इनपुट्स आहेत. सॉरी, येस, 0 as to 7 that means 8 बिट, 8 बिट इनपुट्स आहेत. सिमिलरली इनपुट सी इन हे इनपुट आहे आणि बाय डिफॉल्ट ते काय जातं 1 बिट इनपुट, कारण मी इथं रेंज मेन्शन केली नाही. रेंज म्हणजे त्याचा तो बस इंडायसेस म्हणतात, बरोबर आहे. बस इंडायसेस किंवा त्याची रेंज मेन्शन केली नाही तर ते बाय डिफॉल्ट किती धरणार आहे, 1 बिट, राईट. Similarly, this input clock is also input of 1 bit. This output is n minus 1. What is n value? 8. 8 minus 1 is 7. 7 down, 7 as to 0. S. So simply this S is the output of 8 bit. S is the output of 8 bit. Right? And again, you have to write this as a register also. Or in other way, you can write simply output register in single line also. That is also valid. That means this register you can write here also, no problem. Okay, so this is the example of port declaration, module declaration, then parameter declaration. In one example we have covered the all things, and also how to declare the module header. So this first line is always module header. This is the port declaration part, and this is the parameter declaration, right? So this total comes under the module declaration of VHDL. And again I will repeat, module declaration म्हणजेच आपल्या VHDL मध्ये काय होतं, एंटिटी डिक्लेरेशन. त्यालाच आपण व्हेरिलॉग मध्ये काय म्हणतोय, मॉड्यूल डिक्लेरेशनला, एंटिटी डिक्लेरेशनला मॉड्यूल डिक्लेरेशन, राईट. म्हणजे व्हेरिलॉग मध्ये एंटिटी म्हणजे मॉड्यूल, व्हेरिलॉग मध्ये एंटिटी डिक्लेरेशन म्हणजे मॉड्यूल डिक्लेरेशन. एवढं लक्षात ठेवा. समजलंय का हे सगळ्यांना? क्लिअर विथ दिस? All of you clear with this?
Yes, sir.
Okay, fine. We will stop here. We will continue in next lecture with the next part, right? So we will continue with the same point, that is structures and the hierarchy. Okay, so for today we will stop here. If you have any doubt or query, you can ask me right now.